Hi and welcome back. This is gonna be episode 4 and problem number 12 on the LeetCode75 study plan. So yesterday we solved is subsequence, and today we have a new one. It's a medium level problem. Well, let's begin. Let's see what we got. Where's the... okay. Function max area. Let's do some math. Let's see. Let's read the problem first. Let's do it like this. Oh, not this one. This one. Like this, and yeah, we don't need that. Okay. You are given an integer array height of length, and so we're working with arrays. There are n vertical lines drawn such that the two endpoints of the line are I0, I height, index of height. Find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. Notice that you may not slant the container. I'm not even sure what slant means in English. Like this? I don't know. Let's see an example. Height. So this is the type of array we're gonna get. And the output, it's 49. Explanation. The above, so let's see. So yeah, 1, 8, 6, 2. All right. The above vertical lines are represented by array. Yeah, in this case, the max area of water, blue section, the container can contain is 49. So it's like so I have to think about it like, yeah, those lines are actually it's actually like a container with a size, height in this example. So I can go through them, but for example, even if this one seems bigger, I mean taller, it's actually 8. So this one is 7 times 1, 2, 3, 4, 5, 6, 7. 7 times 7, 49. This one would be 1, 2, 3, 4, 5. That's 40. This would be 40. Okay. That's why this container is the largest. Okay. I understand the problem. Now I have to think about what should I do about it. So we just have one array. How would I go about it? Well, I have to loop through the array. That's for sure. That's for sure. I is less than height, length of height, and I plus plus. Let's save this one first of all. Max container. Max container. So what do I need to do? I look through the array. How do I know what I have to consider? For example, I find the first number inside the array. In this case is a 1. What do I need to do with that one? For now, I'm not too sure how to approach the problem. Container 49. There are vertical lines drawn such that the two endpoints of 0 and I height. I'm not too sure. Like, for example, I have the 8. Like, do I need to check all of them? Will checking all of them be like a reasonable solution? Like I start the loop, I have A, I, it gives me a 1. Like, for example, Well, you can construct a container with every number apart from 0. If you have a 0, you don't have any height, so you cannot build. You cannot make a container out of it. So okay, for example, if I have 1, the maximum amount, the biggest container I can construct is I times the length of the array, unless there's a 0. So for example, if I have a 0 here, the maximum container is gonna be like this. If it's like this, yeah, height dot length. With an 8, you can actually build a container even if you don't have another 8. So I can try all of them. So, well, for example, this one in the middle, or these two, for example. The container can be constructed this way and also the other way. I feel like it's almost like the same, because this with this is the same as saying this and this, right? It doesn't matter the beginning or the end. It almost doesn't matter. So I times itself times the length of the array So for example, I have an A. What do I need to return? The maximum amount of water a container can store. How do I know that I checked every possible solution? If it's equal or greater, I can check the index. So for every index, I check the next one. And basically, between the two numbers, I only care about the lowest number. Because, for example, here, 1 and 8, it doesn't matter if it's an 8, if it's a 3, if it's a 1000, because the only container that we can make is this one. So it's 1 times 1. Same thing with this one. You take the 6, and it's 6 times 1. Here you take the 2, and it's 2 times, well, 2. 2 times 1, 2 times 3, 2 times 4. But the 2 with the 1 is 1 times 3. Okay, it seems that I need to only use the lowest number between the two that I'm checking, right? And I also have to compare the distance between the two numbers. But it feels that at some point it becomes redundant. Right? Okay. Max. How do I call it? Max water equals 0. Let max water equals 0. Okay. Let's try. Let pointer for now. For each. But do I even care? I mean, if it's a 1, the maximum I can get is 1 times the length of the array. That's the maximum. But if there's already a 2, like for example here we got a 2, That's already a 12. That's already bigger. I think that I kind of have like a solution, but it's not optimal. I don't feel like it's optimal. So, alright. Well, let new number. No, it's not correct. If new number is more than max water, max water is equal to new number. And now I have to do the calculation of the new number. The new number is height I times height pointer So I'm here, I. But I have to do this with this, with this, with this, this, and this. Not sure. I'm not sure.
Every core computers now have primary control of critical vehicle functions.
This was a 7. not even sure. It's a bit confusing. Because I'm not actually sure how to easily pinpoint what I need to compare. I'm not even sure that I need a pointer. Like, for example, this one. I already said it, the max I can get is 1 times the length of the array. But it's impossible to know a priori what I have, what kind of numbers I have inside the array. It's almost like I need to check everything. I mean, if I do if new number not sure about this. Because I loop the other. I don't need a nested loop. I'm not even sure about the conditions that I need to keep track of. Like, for example, we compare these two. Okay, I know that the container is a 1. This one, I know it's a 2. But see, then this and this is also a 2. I don't need to check it. Why would I check it? I already know. I already know. This and this, this and this. This and this, this and this. But then it's like this, 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 this and this, and then we go this, this. Right? Say this is a 6. Number like before equals height there was something wrong. Height pointer times distance equal, give me a let distance equal pointer minus pointer I minus pointer. So 0, okay. Then let new number equals then we have the height to consider. Let's call it this way, who cares for now, which is, as I said before, the lowest number between the two. So the height to consider is let's do if height pointer is doesn't really matter, lower or equal to height pointer, which is 0, is higher, is lower or equal to height I, then height to consider is height pointer. then this new number that I'm not sure where to use it, but I'm looping. I have I, which is going, and then I also have the pointer, which in this case is 0. I'll just try with that one. So height to consider is I minus the pointer it was height to consider times the distance, console log new number as a distance. It's going on like this. Zero 6 12 0 0 0 36 should be 6, should be 12, should be 6. Okay. For I equals 0, I minus the length of the array, I plus plus. Let distance, let I to consider, then this and that. Not sure there's any different to it. I should be 1. Oh, 0, because it's the same. 6, 12, but this should be a 6. Else I to consider I. So it's a 0, it's a 6, it's a 12, is it? Yeah, 2 times 2. it's a 6. It's a 20. It's a 20. 36. 2148. But this is not good enough. This is not good enough at all.
Welcome home, Columbia. Beautiful, beautiful. Discovery's 4 computers now have primary control of critical vehicle functions. Liftoff of mission 41D, the first flight of the orbiter Discovery, and the shuttle has cleared the tower.
This is not enough. What do I need?
Beautiful, beautiful.
What do I need? Because then I have to check the 8. I have to check index. I have to go back. It's like then I mean, this is what I'm thinking. This is the logic that my mind is trying to apply. I mean, you gotta find that, but we'll think about it later. In reality, like distance, we don't need it because we can just do this. We can just do this. And so we don't need that. Don't need that, right? Then we also don't need this. Because it is this. Or this. And so we don't need that. And we don't need that. I'm still getting the same result, right? Then the pointer. In this case, I don't even need a pointer because it's just a 0. It's just a 0. It's just a 0. Zero. Height y. But I need to do these as well. So you can do this, lat, number, new number, if new number is greater than max quarter, then equals new number. You can do like this, and at the end of everything return max quarter. Which is 48, and that is the same. Well, it's 8. No, as I said before, it's this times the length of the array. That times the length of the array. What if I go from the two extreme, like this pointer and this pointer, then this and this. I can check this with this, then 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 with this, and with this. But for example, you never check like this with this. with this. Nah, no. Am I wrong? I don't even need a pointer here. It almost feels like it's inevitable. Checking those, then those, then those, and so on and so forth. Because what else can I do? What else can I do? I mean, obviously, if you check this one with this one, I don't need to check this one with this one. But it doesn't matter. You still need to check this with all the others. And that with all the others. Okay, I tried. Let's have a hint. Exactly. Loops. A nested loop. It's not efficient. It's not efficient. I'm sure there's a way. Obviously there's a way. Obviously there's a way. But let's see hint number 2, because hint number 1 is 2 pointers. Set 1 pointer to the left and 1 to the right. Always move the points to the lower line. And I don't care. And I don't care to try out every possible container. So as long as I move the lowest line, I'm assured to get the max water. For example, 1.7. Then I move that, and I got this. So that's like 1 times 7. No. I have the beginning, I have the end. Let's say at 0. Let's say a 7. That one is the lowest times the length. Did I move that one? Seven. So for example, is this like pointer minus I. Pointer is the end. So for example, pointer is height dot length. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 minus 0. 9. 1, 2, 3, 4, 5, 6, 7, 8. This example is 8. So it's I plus 1. It's 0, but it's a 1 in the end. And then whatever we get the lowest times, well, if it's greater than 0, obviously. The lowest times the, well, n multiplier, lowest time multiplier, and we save it, max water. Dot length. Yeah, but then try to use 2 pointers. Set 1 pointer to the left and 1 to the right. But that always changes. So for example, if I have like an 8 here and this is a 10, I don't understand, because I can set the pointer whenever I have a condition. Whenever I find something, I can change it. But the other pointer for now is I, and I just goes from here to there. Let's see. but it feels like I'm skipping stuff. I'm skipping stuff. Like I don't understand. Say that's an 8. I have 1, 1, 1, 1, 1. One, one. I mean, I'm checking this with this. Then it says, always move the pointer that points to the lower. Move the pointer that points to the lower line. Then it will point to this, but the loop goes through, so it's this. See? Then I'm here, then I'm here, then I'm here, then I'm here, but I never check these two. I never check those two, which is obviously the greatest one, the biggest. Oh, well, sure. First one or the last one?
Every 4 computers now have primary control of critical vehicle functions.
I do it again. Do I need a different kind of loop for this one? Let's see. This is the problem. Do I need a different kind of loop? No, I feel like I need pointers. I'm not sure how to get to this without doing what I thought I needed to do in the beginning. But that's a nested loop. Because you have, God. Because you have to do this, then this, then this. This. And like I said, then you need to do this. Okay. No, the problem is that I almost feel like I need a nested loop, because I'm looping through the array, but even, I mean, the 2 pointers are the I of the loop, and then a pointer outside, which I go through every time. Well, that's the second point, because I feel that I need to go through the loop multiple times, but each time I'm stepping forward. So I check from 0 to the length of the array, then I check from 1 to the length of the array, then 2 to the length of the array, then 3. Because I feel like if I don't do that, I'll miss something. So I'm not really sure how to approach it. Nice. Doesn't even. Hello. So this and this, and it goes here. This and this goes here, and it goes here. You feel like you need less loop because you're trying to evaluate all combination of 2 lines. That is what brute force would do. Here's the twist. The optimal version simulates this exploration without actually looping twice. Instead of brute forcing all pairs, you use 2 pointers, left and right, starting at opposite ends. Now here's the brain stretch. You always move the pointer to the shorter line, because an area improvement requires a taller line, not a longer distance. So yeah, it's a loop that shrinks inward, but always with a condition-based pointer movement. You're not revisiting combinations, you're just eliminating them intelligently. You don't need nested loops, you need a while loop. See, a while loop. While what? A while loop. Yeah, it felt like it wasn't right. So it's like left pointer. But it is actually kind of nice because it's a new way for me to do stuff. Let right pointer. Oh, right pointer. Zero. Left, right. While left pointer is different from right pointer. While left is less than, what is this? It's the same. It's the same. Okay. In that case, if height left, oh my god. Height left pointer is less or equal to let's go left. It's easier. Left, right, right. If left is less or equal I just need the right conditions, because if you got a 0, for example, we don't even care. So if it's a 0, they're both zeros, -1. Okay. If they're both 0, what do you do with that? You move both of them. What I kind of do. What if they are both 0? Oh, you mean it doesn't care? So it's an extra step, but it doesn't matter in the end. Okay. So I just don't care for now. So if height if height right is less or equal to, if they're equal, you move it. You like to move it, move it. Max water is equal to n. I don't need it. I don't need it. I said I don't need it. Max water is it is. Shortest one. Well, we're here. This is the shortest. Times right minus left. So, for example, here, I've got a 0 and 1, 2, 3, 4. But it's a -1. So 3 minus 0. 3 minus 0, 2 minus 0, 1 minus 0, 0. Right minus left. And then left is equal to that one. Right minus minus. Right minus minus. Else left plus plus let's check it. So if this one is less or equal to this, then we move this one right minus minus, and this one becomes height right, which was the lowest one, times right minus left. But if the lowest one was left, then we do left times left plus plus. And we've got a 0. Very much 0. Right minus left, yeah. Height, right. Okay, left starts from 0. Right starts from the end, the length of the array. Height the array height length maybe it's length. My god, console log right. 3. Yes, that's correct. Then, while left is less than right, we continue. If zero, 1, 2, 3 is if this one is less or equal than this one, so for example, what's gonna happen here? Is it less or equal to? Yes. So we're here, and max water becomes the height so this times 3 minus 0, which is I need another if this one is greater than max water, then only then we do this. But we always do this, no matter what, right? So same concept, and we take this one, this, so if that calculation is, so we shift the pointer no matter what. If it's greater or if it's lower, we need to shift it, right? But we update max water only if the calculation is correct. Only if the new number is greater than max water. Now it should be correct. $24. $49. Let's add a bunch of zeros. 0, 0. I should get 12. I should have gotten 12. I'm getting 8. It's not correct. Why am I getting 8? Because let's try to do it. 0 and 0. Right, okay. Then 0 and 3. I'm here. Else. So here. 0 and 3 again. Here, shifts. Not 2 and 3. 3, 6, 9, 12. 12, my friend. And this is 2. And this is 0, 1, 2, no, 1, 2, 3, 4, 5, 6, 7, 8, 7, 7, 0, 1, 2, 3, 4, 5, 6, 7, 6. 6 minus 2. Oh, sorry. Yeah, it's not 3 times whatever, it's 2. It's the lowest one. This is a 4. This is a 3. 6. This is a 6. And this one is correct. 100%. Like this. I think I solved it. Twice. Kimberly. You repeat the expression height. Okay, yeah, that can be simplified. Width. No, okay, but it's the logic is exactly the same. I mean, the code itself won't change. So the area, yeah. Let's see. Accepted. Submit. A very nice result. Oh, what I mean, it always, you know, once you're around 1 millisecond, 2 milliseconds, doesn't really matter. 1, 2, 3. I mean, unless you have like an infinite amount of stuff that you need to compute. I mean, the code is solid, and once again, it seems there's always a way to do this kind of stuff using 2 pointers. I got stuck in the beginning because I was trying to use the usual the for loop, and then at some point I was like, do I really need the for loop? Because it really doesn't seem to work. And indeed, we needed a while loop because we didn't care to loop through the array itself. We just needed to loop and, you know, end the process by our terms, you know. So we shift the pointers left and right, and when we find the condition, it's over. Oh, that's very nice. It was very nice. Okay, that's it for today. It was another one. Container with most water. Solved it. And 12 solved. 63 left to go. So we'll see you tomorrow.